हेलो एवरीवन, हाउ आर यू? कैसे हैं आप लोग? राइट, मोनिका, गुड इवनिंग. Right, it's time to discuss that is the basically for the ESE, right, 2020 that is called material science. On the material science we are going to discuss about the electrical and the magnetic property of the material, right? Surya Rajesh, hi. Now the classification of the dielectric material, right? So we have classified the polarization in the yesterday class in the 4 or 5 types, right? That is the electronic polarization, ionic polarization, spontaneous polarization, space charge polarization. That type of polarization we have discussed in the yesterday, right? Now it's time to discuss about the electrical property of that material. By the dielectric, we can split the material into the 4 parts. That will be the first part is the piezoelectric material. We have discussed about the piezoelectric material in the yesterday class. Now the second one is the pyroelectric material. Third one is the ferroelectric material. Ferroelectric material is very, very important, right? For ESE. For engineering services examination, the ferroelectric material is very important. And now in the last, that is anti-ferroelectric material, right? Now, if we'll discuss the next, the piezoelectric material we have discussed, and we did one numerical also in related to piezoelectric material. Piezoelectric material, nothing, it is just a when electric field is applied, or we can say that when strain is applied to the material, then it gets polarized, and due to the polarization the voltage will generated, right? And the reverse effect is also, we know that is called electric extraction. We will discuss in the later. Now we are going to discuss about the pyroelectric material. What is the pyroelectric material, right? Now for the pyroelectric material, the charges produce with change in temperature, right? So when the temperature is increases, then the charges will be generated, right? The second one, these material possess the spontaneous, इसके पास spontaneous polarization होती है. Spontaneous polarization that occurs in the fresh material. When there is no electric field is applied, then there will be the polarization. That polarization is called the spontaneous polarization. Without applying the electric field, the polarization which is present inside the material is called what? Spontaneous polarization. हमने कल डिस्कशन किया भी था, right? So अगर आप इलेक्ट्रिक फील्ड अप्लाई नहीं करते, if you are not applying the electric field, then a polarization which is present inside the material is called spontaneous polarization. And in the pyroelectric material, there will be the what? Spontaneous polarization, right? There will be the spontaneous polarization. Now the direction of the polarization cannot, right? Now when the electric, now okay, just forget about this point, just move on the last point, right? As temperature increases, okay, we know that there will be the spontaneous polarization. Now what happened when the temperature what happened when the temperature increases? Now when temperature increases, due to the thermalization, the dipole polarization, or we can say that the polarization of the system will decrease. So in this case, we can say that as temperature increases, the polarization will decrease for this, right? Change in polarization, right? Charge produces in change in polarization. Now we can say that now for this point, if we are applying the electric field, then there will be the polarization, right? Which align in the what? In the direction of the electric field. Now if we are changing the direction of the electric field, then the direction of the polarization does not change. The direction of the polarization cannot be reversed by reversing the direction of the electric field. Electric field को change करने पर भी polarization में कोई direction में कोई changes नहीं होगा, right? ये एक important point है इसके लिए. And temperature के बढ़ने से polarization कम होता है. And the most important for the pyroelectric, that is the example BATiO3. BATiO3, that is the best example of what? That is pyroelectric material. Now, next, remember one thing for the pyroelectric material, delta P is nothing, it is just a lambda into delta T. Delta P is the change in polarization, and the delta T is nothing, it is just a what? The delta T is the change in temperature, and lambda is the pyroelectric coefficient. It is always negative. So if you want to sketch the graph between the del P and del T, then the graph will be looking like this. If you want to sketch the graph del T versus del P, So there will be the lambda, the slope, it will become the slope, and as we know the delta is negative directly given in the problem, so we can say that that possesses the linear graph. That possesses the linear graph. So just write down this one. Just write down this one. Now if we'll move on the next, that is called the pyroelectric material. Now for the next, there will be the one question, Vikas sir, communication and control का सॉल्यूशन प्रोवाइड कर दीजिएगा, जैनिक वो आप लोग कुछ कर ही नहीं रहे. ओके विकास, आई गॉट योर पॉइंट, राइट. कम्युनिकेशन एंड कंट्रोल का सॉल्यूशन. ओके, नाउ for the next one, that is called third one, ferroelectric material. That is the important. What happened in the ferroelectric material? There will be the domain. All the material is split into different domain, right? And each domain consists of the similar dipole direction. So if I am taking it is as a whole domain. So in the domain or that separation of the each domain is called what? Domain wall. जो separation है domain का, that is called domain wall. उसको हम domain wall कहते हैं. और हर एक डोमेन में जो पोलराइजेशन होगा उसकी डायरेक्शन एक पर्टिकुलर होगी, राइट. जैसे फर्स्ट डोमेन के अंदर डायरेक्शन ये है, इन द सेकंड डोमेन द डायरेक्शन विल बी दिस वन, थर्ड डायरेक्शन विल बी दिस वन, एंड दैट इज फॉर द फ्रेश ferroelectric material. If you will see the fresh ferroelectric material, then the domain will be entire material will be split into the small domain, and in the domain the polarization is similar. So इस डोमेन में पोलराइजेशन एक जैसा होगा, इसमें डिफरेंट होगा, इसमें डिफरेंट होगा, इसमें डिफरेंट होगा, राइट. नाउ व्हाट हैपेंड व्हेन द इलेक्ट्रिक फील्ड इज अप्लाइड? नाउ व्हेन द इलेक्ट्रिक फील्ड इज अप्लाइड, देन all the dipoles is starting to align in the direction of the electric field, right, this. And when for the high electric field is applied, then all the dipoles should be aligned with the what direction of the electric field. वो electric field के direction में ही align हो जाएगा, जैसे कि यहाँ पर हुआ है, dipole parallel to the electric field direction. So just remember few point about the ferroelectric material. पहला, separate domain होते हैं. Electric field जब apply करते हो, all the dipoles are aligned in the field in the direction of the electric field direction, right? Now, this material exhibit the phenomenon of hysteresis. We'll discuss about the hysteresis in this class. It possesses the spontaneous polarization even in the absence of the electric field. So if there is the electric field is not applied, if I am saying electric field is equal to 0 for this case, then the polarization is not 0. The polarization is not 0. There will be the some residual polarization will present always. That is called the spontaneous polarization, even in the absence of the electric field. The third one, the direction of the polarization can be reversed if the direction of the electric field is changed. Now, if you want to change the direction of the electric field in this direction, then the direction of the polarization will also change, and it will be in the opposite direction, which is in the direction of the what? The electric field. So, what happened in the previous that is in the previous we'll discuss about the what जो हमने सबसे पहले वाला previous वाला discussion किया था, that is pyro के अंदर इलेक्ट्रिक फील्ड के डायरेक्शन को चेंज करने से पोलराइजेशन के डायरेक्शन में चेंज नहीं होता है. बट इन दिस केस वी कैन से दैट इफ द इलेक्ट्रिक फील्ड डायरेक्शन इज चेंज, देन द पोलराइजेशन इज ऑल्सो चेंज. नाउ द डायरेक्शन ऑफ द पोलराइजेशन can be reversed by reversing the direction of the what? Electric field. And the third one, these material ferroelectric up to, these material behaves as a ferroelectric material up to a temperature called Curie temperature. If will increase the temperature above than the Curie temperature, then this material will be converted behaving like a what? Piezo, or we can say that the pyroelectric material. It will behave like a pyroelectric material, right? Now, what about the hysteresis loop? What about the hysteresis loop? So just remember about the hysteresis loop. So I'm just sketching the graph with the P with respect to E, right? I'm taking the graph. So there will be the some point I'm writing. That is the initial. So if will increase, so if will, that is O, that is A, it is I'm taking as a B, it is I'm taking as a C, D, E, F, and that again E. So that is called hysteresis, which is followed by what? That is followed by the ferroelectric material. That is for ferroelectric material. That is for the ferroelectric material. what happened in the ferroelectric material? When we increase the electric field, then the polarization will also increase and it will follow the path OA. It will follow the path OA. But now, when we are decreasing the electric field, then the polarization will also decrease, but it is not similar to the OA. It will follow the different path. And so if it will follow the different path, so there will be the electric field is 0. And now there will be the polarization is present. This type of polarization is called residual polarization. Residual polarization. This is called, my dear friend, this is called residual polarization, right? Yes, there will be the one question, Vipin Jaiswal. Sir, in the polarization, first domain wall extension होगा या orientation of the dipole first होगा? जैसे जैसे आप इलेक्ट्रिक फील्ड को पढ़ाते हो, इसकी जो कॉलैप्स, जो वॉल है, दैट विल बी द कॉलैप्स, ये कॉलैप्स होने लग जाते हैं. और एट द हाई इलेक्ट्रिक फील्ड द ऑल द एंटायर रीजन विल बी इन द सिंगल एंटिटी. ये एक सिंगल एंटिटी बन जाता है, वॉल खत्म हो जाता है सारा. नाउ द गोलक, इज दिस टॉपिक also important for the ISRO? In the ISRO there will be the material science, but that is not material science like this. There will be the only for the electric property, but we cannot expect. हम कह भी सकते हैं कि ये होगा भी और नहीं भी हो सकता, but yes, that is for the ESE. Definitely it is the important. ESE definitely it will be the important. Right now, if we increase, so if we are decreasing the electric field, so there will be the some polarization. So that polarization is called residual polarization. Now, अगर हम इलेक्ट्रिक फील्ड की डायरेक्शन को चेंज कर देते हैं इन द अपोजिट, देन इट विल फॉलो द पाथ BC. हम इलेक्ट्रिक फील्ड की डायरेक्शन को और कम कर दीजिए, देन यू विल फील द पोलराइजेशन विल बी फॉलो द पाथ CD. राइट नाउ दिस पोर्शन एट विच द इलेक्ट्रिक फील्ड इज द नेगेटिव एंड द पोलराइजेशन इज 0. दिस इज कॉल्ड कोरिसिव फील्ड. दिस इज कॉल्ड कोरिसिव. This is called coercive field. इसी को हम coercive field बोलते हैं, right? That is called the coercive field. Just remember. Now, and after that, by the following, we are increasing again the electric field. Then it will follow the path EF, and after that, it will move on the A. So that is called the hysteresis loop, right? And hysteresis loop is followed by what? It is followed by the ferroelectric material. So just remember in the few things related to the ferroelectric material, that is very important for the ESE. What? First, related to the domain. When electric field is applied, then the wall will be vanished, and all the crystal will it will seems as a single crystal, right? And electric field is the direction of, and the polarization is the direction of the electric field. And as electric field or we are changing the direction of the electric field, the direction of the polarization is also changed, right? So this is important. Sir, you study very well, but you are too late. It's time to revise all subject now. I watch only for your class. Oh, Rohit Kumar, thank you dear, thank you. But I don't know, but अभी टाइम है, थोड़ा सा टाइम बचा है हुआ, आप चाहें तो आप देख सकते हैं इन सब चीज़ों को. Right now, behaving like the piezoelectric material. Now, what is the example of the piezoelectric material? That is called Rochelle salt, KDP, PbTiO3 and alum sodium nitrate. That is the example of what? The example of that is ferroelectric material. Now, if we have seen that the after the Curie temperature, the ferroelectric material will convert it into the piezoelectric material. So what is basically the nature? I'll sketch the graph for particular this, right? So just listen the first important thing, that is the Curie vessels. But what happened in this? I'll explain you. That is polarization and that is right, or temperature, that is we are changing the temperature, right? So for the Curie temperature, if you are increasing the Curie temperature, it will follow the path what? It will follow the hysteresis. So the polarization curve will be looking like this, right? But at the T equal to TC, I am writing the Curie temperature, that is called TC. Above the TC, it will be converted into what? That is the ferroelectric, that is called piezoelectric material. So just remember one thing, the ferroelectric material will convert it into the piezoelectric material if the temperature we can increase above Curie temperature. So if you increase the temperature above than the Curie temperature, then definitely the ferroelectric material will be converted into what? That converted into the piezoelectric material, right? That is in the piezoelectric material. So now just remember one thing more that is important. Curie versus law. Curie versus law. That is what is the temperature, right? For finding out the temperature. So just remember the polarization is related to this, that is P equal to C epsilon naught upon T minus Q, and where this Q is nothing, it is just a what? Curie temperature. I am writing as a Curie temperature. It is a Curie temperature. So the polarization and electric field is related to the related by the Curie temperature also by this formula. There will be the derivation, but what for this no need of the derivation, right? Now we all are aware about this formula also. We have derived that expression in the yesterday class. That is P equal to epsilon naught xi. Xi is the electric susceptibility, right? Susceptibility into E. Now in the formula, what is C? The C is the for the C, that is the called Curie constant. The Curie constant is given by N into PP. PP nothing, it is just a permanent polarization square upon 3K epsilon naught, right? Good evening, Devendra. Now, the electronic susceptibility, that is Xi, is equal to C upon T minus Q. C is the Curie constant, Q is the Curie temperature, and T is the temperature at which we want to calculate the susceptibility. Now, if you want to find out the Curie temperature, then formula will be Q equal to NPP square upon 3K epsilon naught. 3K epsilon naught into gamma. Now what is the gamma? Interfield constant. The gamma is called interfield constant. Gamma is called the interfield constant, right? Again I am writing Curie versus law, important. What is the P and E relation? That is the C epsilon naught upon T minus Q. What about the C? That is the Curie constant, or we can write the formula P equal to epsilon naught Xi into E. Now what about the Curie constant? Curie constant is represented by N into PP upon square, PP square upon 3K epsilon naught. What about the susceptibility? That is C upon T minus Q. Q is the Curie temperature, T is the normal temperature, and the C is nothing, it is just a Curie constant. And if you want to find out the Curie temperature, that is Q, then it will be NPP square upon 3K epsilon naught into gamma. Gamma is nothing, it is just a interfield constant. So if you want to find out, right? So by the susceptibility, we can also explain this graph. That is the graph susceptibility versus temperature graph. So if we want to sketch for this, it is called Q. That is called the Curie temperature, right? That is called Q. So above the Curie temperature, it will be behaves as a what? Piezoelectric. Piezoelectric, and before Curie temperature it is ferroelectric. So it is the ferroelectric material, right? Now just note down this one. So this graph is important, this graph is important, and the hysteresis loss, this graph hysteresis curve is also important for the ferroelectric material. Now after that that is the that is the ferroelectric material, right? Now the domain we always know, if E applied, then all the domain wall collapse, and it is growth of the single cross, right? Growth of the single crystal. It will be looking like what? A single crystal. Now the second one is the anti-ferroelectric material, right? What happened to the anti-ferroelectric material? For the anti-ferroelectric material, dipole are aligned in the anti-parallel direction. Dipole are aligned in the anti-parallel direction. What do you mean by anti-parallel direction? So I'm just sketching it. If you want to find out the dipole polarization inside this material, then it will be looking like this, this. So if you want to find out the net polarization inside the material, then the net polarization inside the material is nothing, it is just a 0. Because in the opposite direction, the polarization is what? It remains constant, right? Polarization is aligned. Now we can say that, so zero spontaneous polarization for this. So we can say that for the antiferro, the dipole are aligned in the anti-parallel direction, but they are equal. Now there will be the zero spontaneous polarization. There is no polarization will present for this. These material are antiferro up to the Curie temperature, right? And this temperature start behaving like a piezoelectric material after the Curie temperature. Then in the antiferroelectric material, there will be also Curie temperature, and beyond the Curie temperature, it will again behaving as a what? Piezoelectric material. The example will be lead zirconate, that is PbZO3, and ADP ammonium diphosphate. What about the Curie temperature for the material? So some of the material is given in front of you, and the Curie temperature is also given. That is not that much of important. I'm just giving you as an idea. Now, so just remember one thing. For this, there will be the first ferroelectric material. That is the important. That is important. That is the ferroelectric material. After that, there will be, after the ferro, there will be the pyroelectric material. And after that, there will be the piezoelectric material. So we can say that for this, we can say that all the ferroelectric material are the pyroelectric material. Vipin sir, I think for the antiferro material के लिए nil temperature होगा. Yes, we'll discuss that is the nil temperature also, but we'll discuss that nil temperature in the magnetic field, right? But आप सही कह रहे हो, that will be the nil temperature, right? Now, that is the ferroelectric material. The ferroelectric, or just remember this one, the ferroelectric material, all the ferroelectric material are a pyroelectric material, but vice versa are not true. Now, all the pyroelectric material are a piezoelectric material, but vice versa are not true. So just remember this one, this is important. Right? This one is the important. Now, antiferroelectric material. The antiferroelectric material, right, follow the what? The antiferroelectric material follow the double hysteresis. That is called double hysteresis. So just remember one thing. If there will be the name antiferroelectric material, and for the antiferroelectric material, the double hysteresis loop is followed by double hysteresis. There will be that double hysteresis loop. But in the ferroelectric material, there will be the only what? The single hysteresis loop. We all are aware, right? Just make the note for this. Now, what is the application of the antiferroelectric material, right? Yes, there will be the one question. So, teaching in the satellite communication, is it sufficient to crack is? Sir, good evening, sir. What are you teaching in the satellite communication? It is sufficient to crack the ISRO? Actually, in the satellite communication, we are dealing with the today class we are dealing with the power. That is the important thing, right? Power से related हम चीजों को discussion करेंगे और वो ज़्यादा important होगा, सुनील. Right now, what is the application of the antiferroelectric material? First, supercapacitor. To form the supercapacitor, the antiferroelectric material are required. Second one, MEMS, right? Applications, right? MEMS we are using in the college also. There will be some student having the also, project related to MEMS. Now used in the integration with the ferromagnetic material, high energy storage devices, photonic application, and liquid crystal display, right? Now, there will be some paraelectric material also. In the paraelectric material, it contains permanent dipoles. First one, permanent dipoles. Dipoles are random arranged. Third one is spontaneous. Obvious, there will be the random arrangement of the dipoles. So the spontaneous polarization is always what? The zero, right? When E applied, the dipoles are aligned. We all are aware. And what is the example of this? The ceramic material. This is important. The example of the paraelectric material is nothing. It is just a ceramic material, right? So just write down the ceramic material. Now, the dielectric in the AC field, that is also important. Dielectric in the AC field, right? So if you want to find out what happened in the dielectric in the AC field, So in the AC field, the dielectric constant is split into the two parts, right? That is or we can say that dielectric constant epsilon r is split into two parts, minus J epsilon r double dash. That is important, right? Epsilon r dash minus J epsilon r double dash, right? So we can say that it will split it into two parts, right? Now it is related to the DC and the imaginary part is related to the AC, right? So we can say that when AC field is applied to the dielectric, then it will break into the two parts, the real part and the imaginary part. Now we can say that if F increases, then real part will what? Increase. If F increases, then the real part will increase, right? Right? If no, that is not increase, it is actually decrease. So it will be looking like this. So if we want to sketch this graph, it will be looking like the omega or frequency with the ER double dash. The graph will be looking like this. The graph will be looking like this, right? What type of the question will come? Aditya Gupta, the question is basically, that is the theoretical question generally they will ask, right? Just like for the anti-ferroelectric material, what is the exam, or they will given the one example and asking which type of material is, right? So we have to find out, just like the example, right? I'm just taking you one question for it. After this, I'll give you one question, right? So epsilon r dash, as frequency increases, the dielectric constant behavior will reduce. And what about this? For the epsilon double dash, that is the imaginary part. For the imaginary part, as frequency increases, then the epsilon r will also increase and it will reach to its maximum value. After that, it will again start to decrease. So it will be looking like, this graph will be looking like this, right? And just remember one thing for this, at low frequency, we can say that for the low frequency, epsilon r is dominant, epsilon r dash, and at high frequency, epsilon r double dash is dominant. This part is dominant, right? Okay. Before going to this, I'll give you one question. Just write down the question. Piezoelectricity is the reverse effect of. That is the IS question actually, right? IS, or we can say that ESE question, right? Write down, just solve this question. The piezoelectricity is the inverse of, or the reverse of the effect of, right? There will be the four option. A option, electroluminance. B option, there will be the electrostriction. And for the C part, Peltier effect. And the D part is the Seebeck effect, or we can say that Hall effect, right? Just give me the answer for this question. That is the ESE question. The piezoelectricity is the reverse effect of what? The electroluminance, electrostriction, Peltier effect and Hall effect. Just give me the answer, everybody. We have seen the Peltier effect, na? Peltier effect and Seebeck effect, that is the difference, right? Okay, Monica Rani is giving the answer D. Sunil is giving the answer Hall effect. Golak is giving the answer D, Hall effect. Piezoelectric effect and Hall effect. Okay. Vipin Jaiswal is giving the answer B, electrostriction, right? Just remember one thing. There will be the electrostriction. The answer will be electrostriction, right? Okay. What happened in the piezoelectric material? First, just remember what happened into the piezoelectric material. In the piezoelectric material, when the force is applied, or we can say that the strain is applied, then strain is converted into the what? The charge. By the strain, we can convert it to the charge, right? Or electric field, we can say that. But some material get strain when the electric field is applied. In the electrostriction, some material, right? Some material get strain when electric field is applied. Electric field is applied. But in that type of material, the reverse is not possible. In this type of material, the reverse is not possible, right? So we can say that reverse effect is not observed. But reverse effect is not observed. But reverse effect is not observed. Effect is not observed. Is called electrostriction per material. And this property is called electrostriction, right? This property is called electrostriction. So, yes. Now the answer will be what? The answer will be B only, right? The answer will be B only. So just remember one thing regarding to this. The piezoelectricity is the reverse effect of what? The reverse effect of electrostriction. And that is nothing, it is just a ESE question. So Aditya, are you getting the point? What type of question actually asking in the electrical in the class, right? So in the next class, we'll discuss about for the ESE especially, we'll discuss about the what? We'll discuss about the magnetic property of the material, right? That is ferro, anti-ferro, but in the influence of what? The magnetic field. And after that, there will be the superconductor. That is the very excellent topic, the superconductor, and it is also important impact. Yes, there will be the Vipin Jaiswal is asking about the Peltier effect. So Vipin, actually there will be the video present in the Peltier effect, right? That in the first video. If you will see in the first video, then there will be the Seebeck effect. Do you remember the Seebeck effect? What is Seebeck effect? The opposite of the Seebeck effect is called the Peltier effect. The opposite of the Seebeck effect. What happened in the Seebeck effect? There will be the different, if there will be the temperature are difference in the both, then the electric field will be generated, right? But when the electric field will be generated, then the node will be, some node going to in the high temperature and some node is going to the low temperature. That effect is called the Peltier effect. It is just a reverse of what? Seebeck effect, right? Okay, dear. Yes, the B option is the correct, right? So just write down. In the next class, we'll discuss about the magnetic property and the superconductor. Till that, thank you very much. All the very best.